to talk about routers that are pretty horribly broken, and then you can't fix them apparently, but you are going to break them to fix them if they are broken. Good?
Sure.
I'm a lawyer. I do what I can. Let's give our next speaker a big round of applause.
All right, thank you everybody, and welcome. So this is Help Me Vulnerabilities, You're My Only Hope. And this talk is about using vulnerabilities to determine if your MikroTik router has been exploited. And I actually talk a lot about code that I wrote and data I collected. And I actually just pushed this all to GitHub this morning. Slides are up there too, so check that out when you have a chance. And here's just the talk's agenda. I'll start with some background on MikroTik and why their routers are interesting. In the middle, I'll present the problem MikroTik administrators are facing, and then I'll present a solution to that problem. Finally, after we get root, we're going to do a brain dump of all the fun places attackers can hide in router OS that I know about. But I'm going to start with a very brief introduction of myself and some work I've done. My name is Jacob Baines, and I use the handle Albino Lobster. I work at Tenable as a member of the zero-day research team. And on the research side, I really like working on MikroTik routers. The system design is fairly interesting, and it uses a custom protocol that's fun to interact with. And I've written about the routers a few times, as you can see, and that's my bald head up there at DerbyCon last year talking about the custom protocol. And I've also found a few vulnerabilities in the system, a couple of which will be featured in this talk. But not everyone's familiar with MikroTik, so I want to introduce the victim. MikroTik is a Latvian company, and they produce networking devices and associated software. And the products they sell are deployed around the world, and for a few reasons, they have a very enthusiastic user base. Not just on their MikroTik forums and not on places like Reddit, but also they hold MikroTik user meetings across the globe, which can yield some pretty interesting results. And I'll speak about that in a little. But like I was saying, MikroTik makes routers, and since I work on these routers a fair amount, I inevitably try to talk to my coworkers about these. Unfortunately, I believe this is what comes to mind when I'm talking to them, just this little Soho router, which inevitably yields this expression, because who really wants to listen to some guy talk about a Soho router for months on end? But when I think about MikroTik, this is what I'm thinking about. This is a cloud core router, and it has 36 cores, and it advertises 28 gigabit per second throughput. And what's really interesting is that little Soho and this big router, they actually share the same operating system called Router OS. Now this router is good enough for a large enterprise or an ISP, and in fact I know it's used by ISPs because they like to show up to these MikroTik user meetings and give a presentation on their ISP deployments featuring these MikroTik routers. You don't have to take my word for it. I linked a bunch in here. And I actually stole this screenshot from a small ISP in the Philippines. You can see it's just a handful of cloud core routers in a rack. And of course, you can actually find quite a few MikroTik routers on Shodan. The router does have a bunch of management interfaces, so it's kind of hard to get an exact number on how many are internet facing, but you can see the web interface right there is about 600,000. But one interface you won't find on Shodan is for this guy, and this is the screenshot of their management client called Winbox. It uses a custom protocol over 8291 in order to communicate to the router, and as far as I know, none of the internet scanning search engines actually index this, which is really unfortunate because most of the recent vulnerabilities for MikroTiks, they use port 8291 as the attack vector. However, back in March, before they got krebsed, Packettel did an internet-wide scan of TCP port 8291, and they actually tossed the results up on their website. The website's now kind of down, or last I checked it was, but you can grab the results off the Wayback Machine. And what you find in that data set is 3.6 million IP addresses that respond to that TCP scan. And that's a pretty useful data point, I think, but doesn't say exactly how many are really MikroTik routers. And since last year, I'd actually released a library that can talk to this MikroTik protocol. I figured, well, why don't I scan these 3.6 million addresses and determine which ones are MikroTik? And so that is what I did. I wrote the scanner, and it ran in late June into July of this year. And mind you, the packet-tail data was from March, so it was getting a little stale, but I was able to identify 500,000 MikroTik routers with their WinBox exposed to the internet, which according to MikroTik itself is a pretty big no-no. Also interestingly, at least 40% of the scanned routers were vulnerable to a firewall bypass that I had published in February. So that's just our first indication of the poor patching practices. So this pie chart itself is not super interesting, but I have a specific point I want to make here. You can see that 60% of the devices I scanned have been patched in the last year, and that's that rather large chunk that says newer than 6.43 RC4. But everything else is more than a year behind in patching. Most notable is the older than 6.28 chunk, and router OS 6.28 is more than 4 years old now. And all I'm really trying to say here is MikroTik administrators are not well known for their good patching practices. So that leads very nicely into this section. MikroTik routers have seen a number of exploitation campaigns over the last few years, so I want to discuss some of those. So we can start in 2017, and WikiLeaks released Vault 7. And Vault 7 contained this zero-day exploit that was called Kaime Red. Now, Vault 7 didn't actually contain the exploit code or an explanation of how it works, but MikroTik did issue a patch, and as far as I know, Big Nerd 95 here was the first to reverse it and figure out how it worked. And it's an unauthenticated stack clash in the web server. And as we've seen, there are about 600,000 web servers currently available. And about a year later, in February 2018, Kaspersky published their research on Slingshot APT. Now, Kaspersky noted that Slingshot had exploited MikroTik routers with an unknown vulnerability in order to replace some DLLs on the router. And the DLLs actually get downloaded by the WinBox client. So not only did Slingshot exploit these routers, but they're able to exploit the downstream admins as well. And still, not long after that, in May 2018, Talos released their first iteration of their VPNFilter work. And MikroTik routers were also caught up in that. Again, no specific vulnerability mentioned, but MikroTik's official statement implied that the exploit was Kaime Red. Although I personally take that with a grain of salt. Either way, I want to point out this FBI notice that simply states for everyone to reboot their routers, and we will see later that that is not going to remove malware from a MikroTik router. So this is more of an ongoing thing to my understanding. This is a picture from a very nice analysis done by Trend Micro on Trickbot from March 2019. And you can see the threat actor was actually using exploited MikroTik routers to run command and control on their installed Trickbots. It's a great way to stay hidden, but really not great for the router owners. So this post actually appears on the MikroTik forums on April 20th, 2018, and it basically says, someone has logged into my router, and now I have a couple weird bash scripts in my user directory. And a couple posts after that, a guy running a wireless ISP comes on and says, yeah, we're seeing the same thing. And so this turns out that it was actually 0-day being used in the wild. And 3 days later, MikroTik actually issued a patch for this, which is a pretty good turnaround in my opinion. And their statement basically says, someone with a custom tool can connect to the Winbox port without authentication, download the user database, and recover usernames and passwords. But that's it for details. There was no POC, there's no CVE. But a month later, a couple of researchers posted this analysis of the vulnerability, and shortly after that, they published a working POC, and then after that, finally CVE 2018-14847 was assigned. And the POC they wrote actually gives the attackers credentials they need to log into the router and start messing with the configuration. And as we've seen, MikroTik routers don't get patched very quickly, so people kind of ran with this. One of the things they did was inject CoinHive JavaScripts into the custom 404 page that the router can serve up. This is a tweet from Bad Packets Report, and it was around the peak of this CoinHive madness in October 2018, which you can see 250,000 affected routers. But other attackers had other ideas. One of the good features of MikroTik routers is that they support packet capture and forwarding. So according to NetLab 360, about 7,500 routers have their packets forwarding to a third party. And another attack mentioned by NetLab had nearly 250,000 routers with their SOCKS 4 proxying enabled just for this one specific net block, which I thought was both weird and fascinating. And I've skipped over other threats like Kame Blue, but I think you guys kind of get the idea at this point. And the reality is none of this stuff is really going away. So this is a tweet just last month from Gray Noise. And if you're not familiar with Gray Noise, they have honeypots all over the place. And you can see here they notice a very large increase in scans for CVE 2018-14847 just last month. And I'd actually written and deployed my own Winbox honeypot around that same time period. And while the numbers weren't crazy, almost every connection to the honeypot was an exploitation attempt. And it only took about an hour and a half of the honeypot being online before the first exploitation attempt rolled in. And again, like everything in this talk, both the code and results are up on GitHub. And of course, this is a sort of different kind of threat. Zerodium tweeted this earlier this year, and this offer is still on their website last I checked. And while this isn't Apple 0-day money, it certainly isn't nothing either. So presumably, Zerodium has someone they want to sell this to. So why did we talk about all that? Well, hopefully I convinced you that these routers they're not just little home routers, but they're also big, beefy enterprise RISP routers. And they've been exploited quite a bit. But what is the problem I'm here to talk about? So this is the problem. From left to right, you're looking at Winbox, WebFig, and the MikroTik terminal. And this is more or less what the administrator has to interact with the device. When what you won't find is a real shell, any way to access the underlying file system. The administrator really runs in a jail, and they just don't have any way to know if they've been exploited. And I'm not the only one to notice this. This is just a small sample of people on the MikroTik forums wanting to know how they can tell if they've been exploited. And this is actually MikroTik's official statement in response to CVE 2018-14847. I highlighted the good part. You can see it says, there's no way to know if you were affected. And the security community isn't much better, because what do we do? We write nice blogs. I'm certainly guilty of that, and we publish file hashes. but a MikroTik administrator can't actually access the file system, so the file hashes aren't incredibly useful to them. So that's kind of where the MikroTik community is, blindly hoping they weren't exploited, or if they've upgraded, that actor has been pushed out. But to my thinking, that isn't very acceptable, because there are serious implications for any person or organization with a compromised router. You really do need to know if you're affected or not. But without any type of official solution and really no other alternative, we turn to our only hope, and that's the vulnerabilities themselves. So perhaps we can jailbreak these routers and get some answers. But there is one immediate problem with my plan, and that's the number of architectures that RouterOS actually supports. I think MikroTik has a goal to collect all the architectures. But writing and maintaining stable shellcode for all these architectures would surely be an obnoxious task that I certainly was not willing to undertake. The other problem is MikroTik releases so many versions of RouterOS. They have even released a version since I gave these slides to DEF CON. And you can see since 2013, they've released about 2 official versions per month. That's ignoring all the release candidates. And that's just a lot of versions we need exploits for, and it would be tough to test stable exploits across all those versions. So that's kind of 2 strikes against my vulnerability saving the day plan, but this is our saving grace. RouterOS has a backdoor in it. It's there on purpose. If a special file exists in a specific location, you can log in as the devel user and get a root busybox shell. And I cannot emphasize enough, users cannot, they should not, and they were never intended to be able to make this file and get this root shell. But I think with some help from our vulnerability friends, we might be able to get root and answer some questions. So here's the first vulnerability. This was actually found by Hacker Fantastic, and it was dropped as a 0-day on December 11th, 2018, and MikroTik shortly followed up with some patches. This vulnerability has no CVE, and it's just a simple arbitrary file creation bug. You literally just tell the telnet client to create a file. Pictured here, you can see that I tell the telnet client to set tracefile /ram/package/option, and that just happens to be the backdoor file. I then log in as devel and get a busybox root shell. And just a quick note about vulnerabilities requiring authentication on RouterOS. The system ships with a default admin user with no password. And neither login for the web interface or the Winbox interface have any sort of brute force protection. So I've written a couple of POC to prove that out. So while Hacker Fantastic's bug does require authentication, it's still quite serious. But back to the bug itself. When Hacker Fantastic dropped this vulnerability, it was just a basic breakdown of how you would manually type in the attack. Writing a full POC requires the author to know how the Winbox protocol works, and since I'm one of the 3 or 4 idiots that publicly understands that, I went ahead and wrote these POC that automate Hacker Fantastic's exploit. And these will create the backdoor file so you can log in as root. So this next vulnerability is one that I found, and it was patched twice, once in March of this year in the stable branch of RouterOS, and then again in May in the long-term version of iOS. Interestingly, MikroTik doesn't actually flag this patch we see here as a vulnerability. They simply call it improved file handling, and they don't even mention the CVE I signed. But either way, this bug is a file traversal bug, and it gives you the ability to both create directories and read or write files. So it's very powerful, but does require authentication. So I have a couple POC for this. Again, it just creates the backdoor and again, it works all the way up through May of this year. Finally, the last vulnerability that we'll be using is CVE 2018-14847. And this is the vulnerability that actually started out on the MikroTik forums. It also turns out that this is a directory traversal bug, and it can also be used to read or write files anywhere on the box. Since I already released an exploit for this back for DerbyCon, there's nothing new to release today. But basically the summary of the situation is we have these 3 great file creation vulnerabilities, and they work over a variety of interfaces, and all of them can create the backdoor file to enable the root shell. And also the MikroTik community has this general problem that they can't determine if they've been owned or not. So I'd like to introduce you to a little tool I wrote. It's called CleanerRAS. And CleanerRAS aims to be a very simple tool. The user simply provides the IP of the router, a username, and a password, and CleanerRAS will do the rest. It'll either try exploiting the Winbox interface or the WebFig interface. It automatically figures out the router's version and then creates the backdoor file however or wherever that version dictates. CleanerRAS gets root on versions of RouterOS from 2011 all the way through May of this year by using the 3 vulnerabilities we talked about. RouterOS's versions 3 through 6 all are supported and all architectures are supported because again none of these vulnerabilities actually require any type of shellcode. Another thing that actually comes with CleanerRAS is a little script called RASSH. All you do is you upload that to your router, and with your brand new root shell, you run it and it will look for all sorts of bad stuff in the router and let you know what is there. So it's really cool that we got root and that there's this little script to find all the bad stuff in the router, but this is DEF CON and we want to know about all that bad stuff. So let's go exploring post-exploitation. And first of all, a small disclaimer. This discussion is really going to focus on RouterOS 6.0 and above, because before 6.0, as you can see, the entire file system was read-write. So you didn't need any special tricks to hide in the system. But modern RouterOS is quite different. It's full of tempfs and read-only file systems, so surviving a reboot is not necessarily a given. Luckily, since the last release of RouterOS 5 was 4 years ago, there's probably no more 5, 4, or version 3s out in the wild. There are. And just one more final point before we start talking about the interesting stuff. If you go home and you decide to root a RouterOS VM or a router you have, do yourself a favor and upload your own BusyBox. The built-in BusyBox is extremely limited, doesn't even have LS, so it can be quite obnoxious to use. So let's start with something simple. Almost everything should be, let me expand this. Almost everything on the system should be executing out of /bin, /bin, or /nova/bin. And these are actually read-only directories that come from digitally signed package that in theory should be totally trustworthy. Shouldn't be messing with stuff. If you see anything executing out of /read-write or /flash, then you have almost certainly been owned. Because that's persistent file space that RouterOS does not normally use for execution. Finally, you should be looking at these /package items. You can see them in the PS output. They need to be analyzed a little closer. But before we look at these /package items, you need to understand that everything in RouterOS is a package. For example, the files in Etsy and the binaries in bin are part of this system package you can see at the bottom of the screen. At boot time, a squash.fs file system is extracted from these packages and mounted as read-only in the package directory. And, I kind of apologize for this Charlie Day slide, but this is all I'm trying to say here. All the packages get mounted in /package, which itself is a read-write directory within a temp file system. And because the package directory is read-write, anyone could add their own files there and execute them. In fact, pictured to the left is a very suspicious looking package/LOL directory. And it has a very scary looking RC script. So what is the takeaway from this slide is basically everything in /package should either be a mounted read-only squash.fs file system or a valid symlink into bundle. Anything else is malicious. So you can see the LOL directory and the option directory do not belong. So while it's true that package is a place that RouterOS executes from, you do want to be careful and make sure nothing new has been introduced. Because if you're just looking at the PS output, you'll get something like this. I'm executing BusyBox. It blends right in. It doesn't belong. So since we were messing around in the package directory, I personally found this tidbit a little interesting. There's this check installation button in the packages UI, and there's not like a lot of documentation for it. There's no documentation that I could find. But also pictured here is a forum post of some guy that left his router open to the internet just to see what would happen. And he asks a good question. How do I know if it's been owned? Will check installation be useful? So I ran check installation with BusyBox running like it was in the previous slide, and you can see that that RouterOS said that's just fine. A different thing you want to look at is the /proc/maps for SNMP, www, and the profiler binaries. And here's a screenshot of SNMP's proc maps. SNMP itself lives in a read-only directory called nova/bin, but you can see that I've gotten it to load a shared object called lol.so. And that's basically because the SNMP library will loop over all the package directories, and if it finds an SNMP subdirectory, it will load any .so that it finds. And this is just part of that SNMP logic. As you can see, it does compare the end of the string versus .so, and if it is true, then it will just DL open whatever. And of course, hiding execution in a shared library is pretty neat. So I wrote a POC that uses CVE 2019-3943 to write this to disk. The POC will then stop the SNMP process and restart it. And that way the shared object gets picked up by SNMP. And then you can see this constructor gets executed. The constructor actually deletes itself and creates the backdoor file so we can log in. And I would again like to take a moment to be very petty and say that MikroTik did not put out any notification to their customers about this CVE. In fact, you're going to want to check the proc maps for all the binaries. And that's because the first entry in the load library path is a directory called /readwrite/lib. And you might recall I said earlier that RouterOS doesn't execute out of /readwrite, and that is normally true. In fact, this directory doesn't even exist. When you exploit the router, you're going to have to create the lib directory yourself. But what's really great about /readwrite/lib is that it lives in persistent file space, so anything we add there will survive reboots. So here we are looking at the proc maps of novabin/fileman, and all of the libraries that this binary actually wants to load should be in the read-only directory /lib. But you can see here highlighted in red that I was able to load libz.so out of read-write lib. And of course, I have a proof of concept for this one as well, but this time the proof of concept is MIPS big endian. And the way this basically worked is I downloaded the real libz, I added this silly constructor, cross-compiled the library, and then I used CVE 2019-3943 yet again to create the lib directory and write the shared object. And eventually FileMan will just restart and pick this up. So this will create the backdoor without rebooting. Speaking of rebooting the system, let's talk about persistence a little bit. One of the challenges with the backdoor file is that in newer versions it actually got moved into tempfs package space. So what that means is when you reboot the router, the developer backdoor disappears on versions 6.41 and above, which is nearly most every release since December 2017. Also, the behavior of upgrades is still sort of a black box. Lots of files are overwritten, some are deleted. But back to read-write/lib, like I said, it survives reboots like a champ. libz in particular gets loaded up somewhere very early in the boot process, so the creation of the backdoor is seamless, and it even works in the most recent release, which was July 19th, 6.45.2, which is actually pictured here. So I actually had very high hopes that I could use this mechanism to persist across upgrades. Unfortunately, or fortunately, depending on your view, the upgrade process deletes the entire read-write lib directory. So still very good for persisting across reboots, very terrible for surviving upgrades. So switching gears yet again, remember that everything on the system is a package, and the packages use the MPK file format. And part of that format is what appears to be some sort of digital signature. Before these packages get installed, the signatures are verified, and then they're stored in the directory /var/pdb. And as I've mentioned before, when the system boots, it unpackages these MPKs and it mounts a squash file system that's stored within. So one weird thing about /var/pdb is that it's entirely read-write. So as root, we can modify these NPK files. And so when I figured this out, I was just wondering what would happen if I overwrote one of these files. So I had a silly experiment where I just echoed LOL over the system package. And the system package, again, is the one that contains all the basic Linuxy stuff, like /bin/lib/exe. So I overwrote it and I rebooted. And I was actually met with this error message. You can see it says no system package found. And then it went into infinite reboot. So I wondered, if I can overwrite a package, maybe I can introduce my own. So I wrote this tool called modify NPK, and it takes in a valid MikroTik NPK and a user created squashfs file system, and it replaces the valid squashfs with the user's squashfs. Now obviously, since we modify the NPK, the signature is totally invalid. But if you take the output from modify NPK and you create your own package in /var/pdb, you reboot the system, what's going to happen? Well, here you can see that I've created a package called RAS, and I've moved it into var/pdb and rebooted. And there you can see that my package actually successfully is installed despite having an invalid signature. And of course, each package has their squashfs file system mounted as read-only. So what did I put in my squashfs file system? An RC script that basically just creates the backdoor at boot time. And of course, since this package was successfully installed, it will survive reboot without any type of issue. But we do finally learn what check installation does, and it appears to validate the MPK files in var/pdb. You can see if a user runs check installation when my package is installed, then it gets flagged as a bad image. Now MikroTik did eventually patch this in 6.42.1, but it's unclear to me if they knew they fixed this or it just happened to get accidentally fixed. At the bottom, this is the only release note that I think could maybe sort of be related. But still, given the number of pre-6.42 installs that still exist, to me this is a pretty interesting persistence technique and sort of an even more interesting developer mistake. So let's talk about RC scripts a little bit. I first saw this in the comment read repository, so I can't really take any credit for it. But in Router OS up to 6.40.9, you just make an RC directory structure off of //xc, and that will be treated like any normal RC scripts. So if you drop something like S18LOL, it will be executed next boot. And again, since this is in Flash, it's entirely persistent across reboots. Super simple, dead easy persistence method. Fortunately, this was fixed. And of course, the system has its own RC scripts off of the XC directory, and there are two that I want to talk about. You can see first the 08 config script. It's very simple. If /r read write reset exists, then it just gets executed. Yet again, another dead easy persistence mechanism, but this was fixed after 6.40.5. But in 6.40.1, the script 12defcf was actually changed so that the contents of read-write-defconf were executed by an eval statement. And this is still the case. Pictured here is 6.45.2, like I said, just released in July. And this is actually the persistence mechanism that CleanRAS uses for these newer versions. But read-write-defconf isn't perfect. It has a couple of issues with it. The first is that if read-write-defconf exists on the system and no one has yet logged in, then it disables login for everyone, including the backdoor. So basically shuts down the device. And the second thing is that if read-write-defconf exists, then upgrades silently fail. The upgrade looks like it was successful, but it will be the exact same version number, no error logs, no nothing. So CleanRAS gets around this login issue by using an RC script off of package that simply moves a staged file to read-write-defconf at shutdown. That seems complicated enough to me that I decided to just make a standalone POC that people can check out if they're interested. Basically, the POC uses CVE 2019-3943 yet again to create a defconf file, and once the system is rebooted, the defconf file will get executed and it will put that persistence mechanism into place. I never found any type of solution for fixing disabling upgrade, so I'm just going to call that a feature. And in fact, I never found any way to maintain execution through an upgrade, although I'm sure it exists. But you know, if you can't maintain execution, what can you do? So my solution was just to drop a symlink, a hidden symlink in the user directory that the MikroTik user can actually access. You can see here I've actually FTP'd into the router and I found the symlink .survival and it's a symlink to root. And it's worth noting if you're using either Winbox or the web client, neither of them show hidden files, so they can't see the symlink. And so this is just an example of me regaining execution using the symlink. You see I have this defconf file, I FTP in, I traverse the symlink, move to the read-write directory, and put defconf. And after a reboot, I log right in as a Devel user, and I have a full shell. Once again, this is 6.45.2, just released in July. And just to prove that the reboot persistence still works, I rebooted the system, I'm logged in again, and I still have my shell. So that's mostly what I have for you today, and that's actually a fair amount of material, so I wanted to just provide a quick summary slide. And I will not sit here and read this to you. This is more for review. Like I said, everything is on GitHub, so you can check out the summary if you want. But I think it's fair to say that I identified a problem with MikroTik routers, offered a solution, and shared various ways I believe attackers could abuse the system. So one of the best parts of any talk, in my opinion, is to get new ideas for your new ideas for your own research. So here are just a few things I know that could be tackled. Recently, both the Winbox and JS proxy login algorithms changed. No one has published anything about those. That would be pretty useful. I have never looked at the NPK loader system. Obviously, we see that it has issues in the past. That would probably be fun to dive into. There are actually a lot of kernel modules MikroTik has written for the system. I have not peeked at any of those. And I did look briefly at package signing and verification, and it looked messed up. But I'm not a crypto guy, so it could just be I didn't understand it. So someone would probably do well to look at that. And of course, we always need more jailbreaks to expand cleaner RAS. And that is all I have for you today. Appreciate everyone coming. Thank you to the goons. And I can take any questions with what time we have left.